Hello guys, in this video I want to showcase CLORE.AI GigaSPOT and how it can be used for renting GPUs and attaching them to Hive OS with this demo that we'll be using the CLORE.AI GigaSPOT Python SDK. In short, to little talk about what is GigaSPOT. GigaSPOT itself is a GPU marketplace part of CLORE.AI. Basically, machines have their electricity price. They can have multiple bits, and the highest paying bit, highest profitable bit for the machine, as shown in this beautiful image, will be run by the machine. It's relatively limited. It's great for proof of work and AI-based cryptocurrencies, and for to run at idle for the machines to await higher paying AI workloads. This docs CLORE.AI is a great resource to learn about the GigaSPOT marketplace and how to deploy on it. We will today showcase how to deploy Hive OS on CLORE.AI marketplace, GigaSPOT CLORE.AI marketplace with this demo. And okay, first we of course need our CLORE account fueled with some CLORE, and we would need an API key. The stuff. This is the demo repository. It's on CLORE.ai public GigaSPOT examples Hive OS demo. And okay, let me switch here. This is the repo itself pulled. I just pulled it onto my computer. I just need to save the API key and API key. Yeah, just save it. Oh, so just to go a little over it, what we have here. Okay, so the main file autobit Hive will automatically deploy Hive OS on the machines. This Hive image ID is ID of this image that is here publicly. This image, anyone can build it, anyone can verify what this image does. It runs Hive OS on CLORE.ai marketplace, and it also allows it to run on GigaSPOT. The eventual more appropriate goal of customers of GigaSPOT is to create their own images with their own workloads that can achieve better efficiency. But for this demo we'll use Hive OS. It's super simple and people can really understand it. We can select the price for what we are bidding on the machine, and yes, we select the price. In this demo it recalculates the price for price per GPU, so we can set our price per GPU at some dollar estimates, which I'm converting to CLORE based on some CLORE exchange rate that I have saved locally, and these are the GPUs that I'm interested to rent, and I can set these offsets. We can show I have here this test.ypy this Jupyter notebook, and we can start the library and query GigaSPOT. The GigaSPOT itself, it comes in templates, so if you want to have a look at what is on the GigaSPOT marketplace, you cannot get it in real time. You can get this template, which the template comes out every 20 seconds, around every 20 seconds. This is because querying the GigaSPOT and building the GigaSPOT marketplace for everyone will be relatively compute heavy, and for enough good bidding it's okay to upload a template to a CDN and then just cache this template from a CDN to the user, so everyone can have it at the same time, some look at it, and it's not bugging down our API. With using this GigaSPOT SDK, you will have no idea what is happening. It will just work fine. We can open up the snapshot. It's relatively large because already some machines are on GigaSPOT, and let's just have a look at the structure. The structure shows whatever the machine ID, if the machine has any bits, if the machine is on demand rented, if the machine is online, that you should only rent. You can only rent machines on. You can put the bits, aka offers, on GigaSPOT only on machines that are not on demand rented, that are online, and I strongly recommend only bid on machines that have this working properly. This is at least some inner check. Please ignore machines that do not have working properly on them. The machines will probably not have it after a reboot, but that's like, but then they will get this working properly through. But I would, if it has faults, just don't look at it. And also this maximum rental length, because this is like the only like way that we can like distribute the state of the GigaSpot and the bits on GigaSpot right here. So we can compare to other people on the market. You will, even if the host hides the machine, so it couldn't be rented anymore, you need to like see it in the snapshot. So if hosting provider hides the machine, this max rental length will be 0, and you couldn't place any more bits on the machine, and eventually the machine will stop being rented, and then it can disappear from the marketplace. It also carries this minimum bit. This minimum bit is calculated at like as like 78% of the top revenue, calculated by hashrate.no for mining on these particular GPUs. It's set at this point, so for the start of GigaSpot we will not underpay the hosting providers. The hosting providers will be already greatly compensated by the CLORE.AI rewards at the time of recording this video, so nobody is carrying some losses, and eventually the GigaSpot market, it'll basically peak, and it'll probably be the best place for hosts to offer their machines, because there will be like so much competition. I really believe there will be like so much competition renting the machines and like just hyper optimizing cryptocurrency mining. Okay, this was a lot of talks, so let's just quickly look at like this Autobit Hive. We connect to a MongoDB database where we have like prepared HiveOS credentials, and yeah, here's this main function that basically gets the HiveOS credentials, gets my bits, and like generally like tries to find if some machine is rentable, like based on these GPU definitions that are imported here. We can like blacklist hosts and machines, which is very important. Some machines can like underperform, or you just want to blacklist them. Note like this, all this code is just a demo, just a showcase how to use the CLORE.AI GigaSPOT library, and itself, like, you can use it, but it's like, just you should understand what this really does. So you should like read the code before you start using it, and you will probably need to like modify it a little bit to your needs. Okay, and so it creates the orders, it cancels the orders automatically. I can probably show it here. Okay, so here is like my MongoDB compass. Here I have 460 HiveOS credentials for the machines, so I can rent it, and here will be like the bits for the machines, right? And it'll create the orders on CLORE.AI and connect it. It's probably better for you if you just read this code a little later. It'll basically get the GigaSpot market snapshot, look at the snapshot, and check if like it will only rent machines if you will be like the top bidding person on the machine. And remember, it's bidding by profitability, so that's why we're calculating with the energy price in the calculations. But okay, everyone's wanting probably to see this. I already installed this like requirements. If I do like, you will firstly need to install the requirements, but they are already satisfied. This CLORE GigaSpot library and this motor library for using MongoDB in async modes. Okay, let's have a look. On HiveOS we have 460 unutilized machines, and what we can do, we have this flysheet for Xano and CLORE. In this example, I just look at Xano, whatever. We'll try up Xano, and what we have here, the hostname. We can get like hostname like this, which will be on CLORE.AI. The hostname is O dash and the order number. The machine ID here, if we have a look back into the code, yes, here exactly it's passed as the environmental variables to the container. So the people are able to just like, you know, get this machine ID and pass it to your miner, so you can like monitor it for mining pool. Also very important, if your production deploying GigaSpot, you should have some kind of like check, is the machine hashing correctly, is the machine like giving you enough power, is the machine giving you the power that you want from the machine, is the machine giving you what you're paying for. That's like somewhat important. You should always like keep it in check, but like it's probably like obvious for you. I just also something what want to mention, if you want to, and also it works on the snapshot, the GigaSpot. So here it has this like cancel all flag, but this is for when you like want to stop your work with GigaSpot, you want to cancel your orders, and on GigaSpot you can use this script and run the cancel all flag, but like you should wait and check if it really like canceled all of your orders. If it really like ended up canceling, then maybe you should rerun it, because you maybe had like older version of the GigaSpot snapshot that's generated every 20 seconds. Maybe there were some new orders and it didn't cancel, just like a good thing. And yeah, so this is it right now, workers. This will be the biggest test of GigaSpot, the initial test, and we should firstly select the Zano flight sheet and put it on. Okay, 250 selected. Or should we will need to go on the other page? Okay, 250 selected. Second page. And also you want to apply the flight sheet. Zano. Okay, 460. Okay, so I selected all of them. Not really that much familiar with Hive. Okay, so all of the workers should have the flight sheet configured, but they are not connected yet. So let's run it. So whatever, yeah, Python free autobit hive.py. Okay, and it also like have some timeouts, the API, so it does some calls on the API. And for example here, these bits. Okay, so we already have like 150 bits. It carries just the machine ID and Hive rig ID, and oh yeah, it is like limited 150 bits per call. Okay, we have put up some bits. Okay, we have only 284 bits. It's probably because these GPU definitions itself, they're like paying too low, or we have like out of bound power limit. I haven't specified necessarily all of the GPUs that could have come. I'm with the GigaSpot, I haven't specified all of the GPUs. Maybe it was just some for this quick showdown. So, but like some GPUs are specified, so we rented some GPUs. If we look on our marketplace, my orders, we have 284 orders. Basically, they are deploying. The image can be like cached on the machines. Yeah, this image, it's exactly as I mentioned, this CLORE.AI public high-voice image. So the source code of the image itself is public. And yeah, we already see some of the machines starting up and catching up and like setting up the miners, right? We can have a look at some of the machines. Remote access. I can start the Hive shell. The CLORE orders are, you can query like by deploying. Okay, there are still like few that are okay. We're deploying. It can take some time. Okay, Hive shell. So itself in GigaSpot, the order has like 600 megabytes of persistent storage. Yeah, we can see the miner. The miner itself is running. Is this? I just chosen this Wilddrake multi. It's just for the demo, basically. Yeah. I mentioned 250 megabytes of some storage, which is enough for just running miners, for bidding on GigaSpot. And okay, well, some machines are still like getting up and running, whatever. Oh yeah, and we're getting some hash rate for Zano. It can take up some time. many of them still deploying. They can be like, you know, on some farm, and like these machines maybe never had the CLORE.AI Hive OS image deployed previously, so they are basically initially caching the image. This CLORE.AI Hive OS image is like one of the few images that are generally, when they are firstly downloaded on the machine, they will be cached on the machine for good, basically, so they don't run away. This is like this CLORE.AI Hive OS image, and also this CLORE.AI Jupyter image, which can also be deployed on GigaSpot. And yeah, it's mentioned, yes, I believe here, Ubuntu. It has this ID for GigaSpot, and you can use this delegated entry point for example, so you can like have some SH script that will be used as entry point. It will be run as supervisor D service. You should, if you're interested in that, you should have a look in the source code of the container, and you should also have a look at the GigaSpot demo, the GigaSpot example for Ubuntu base mining, where it carries this script for. This is just a T-Rex miner. Like, it can be okay enough to set it up this way with like a delegated entry point. It's probably not the correct way to say it, but okay. But you need to like cover the edge cases of like machine being overbitted, basically taken down, or whatever, taken up, you know. You need to cover the edge cases basically. So it's a little more complicated than building your own image. Also, when building your own image, the image itself needs to be under 600 megabytes to be deployed on a GigaSpot. Otherwise, you basically need to upload the image to the CLORE container registry. So what is the state? Okay, 600 GPUs. How much deploying? 110. Okay, it still like takes some time. If we can have a look at open data, actually, yeah. Oh yeah. So we have deployed 166 machines, 700 GPUs on GigaSpot, and in our database we have 184 bits. Okay. Well, wait. Yeah, because it shows like the machines deployed, because on GigaSpot itself, when the image is deploying, because it's being initially pulled, you're not actually paying for the image. You're only paying for the runtime. So if the machine is pulling the image, then you're not paying for that, and it doesn't show as register, because you only pay like the creation fee basically, and not for the running of the image. It's also showcased here on the GigaSpot overview here that it every like 60 seconds is a CLORE.AI billing cycle, which checks which of the offers is like most profitable, which of the bits is most profitable for the hosting provider, and it selects this bit which is like mostly profitable for the hosting provider, and only on this change. So it's like built per minute, and you're running the whole minute. Actually, also like wanted to say, if you like send a GigaSpot bit update, like you're updating the price of the bit, it will update on this CLORE.AI billing period, because we wanted to prevent like issues like person bids high and like then goes low and like get the minute runtime. This cannot happen. It's built and then it's changed. So if you send like edit command to edit the GigaSpot bit, it will still like show the old price until this billing interval happens, which happens like every minute, every 60 seconds when CLORE.AI is running normally. Okay, so it's probably machines like one farm that is like right now pulling over its internet connection really hard all of those Hive OS images. We can, but otherwise, okay, 676 GPUs. Okay, 757. Some are still connecting. You need to somewhat like, you know, manage which machines might be problematic, which machines might not be problematic. I'll pause the video. I will try to return when all they deploy. Okay, so giving a little update, I just fixed this total cost. Previously showed the post orders, like not gigabyte orders included in the cost. Like right fixed, we see like the GPUs. Some of them are connected and some of them are deploying. This is because these machines, it's probably the first time deploying HiveOS 0.3 on them, and it isn't cached. And if they are on like one farm, then like Docker Hub can like ban the machine for some time. It'll like eventually get cached. I just think it isn't important to show it cached for the video itself. There might be like machines like this one that like fail to run the miner. Then if we are on the machine, we can like open the Hive shell. We can like really see that like I just already like stopped the miner because like for some reason the Wildrick multi-miner it keeps exiting, for example. But like if we print whatever machine ID, for example, okay, machine ID, we copy the machine ID and like for example we can add it to the blacklist, and yeah, if it will like itself run, it should eventually like kill the order. If we have it on the blacklist, you can slow. There's something around here. Okay. Yeah, it's been cancelled. So yeah, the blacklist also like somewhat good to use to maximize efficiency. You should blacklist machines that tend to generate issues for you. So that's about it. The caching, you'll probably not seen it in this video. It was nice showcasing GigaSpot 2 and like showcasing this bot for GigaSpot and how it deploys on HiveOS, and see you later.